Hi guys, welcome to my channel. In this video we are going to solve the questions about the study course, and we are going to learn how to draw shear and the moment diagrams and from the graph method. And so let's solve the question. Before we solve the question, if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If anything you want, please comment. I am going to try to make the videos and the channel better for you and for all of us. So let's solve the question. The first one, I'm going to draw the free body diagram of the first part here. For example, I'm going to start from B to C. Look at it says that B is pin and A is fixed. Okay, so if it is B pin, we have two forces. One is BX, one is BY. And for C, we have here a CY. And if we have a distributed load, I'm going to convert to the point load. It's going to be 3,000 pound. Okay, this is 3,000 pound, and we have here as 3 feet as 3 feet. Okay, so let's solve the question. I'm going to take the moment with respect to B. Total moment at B is equal to 0. Okay, and this direction is positive, so it's going to be 3,000 multiplied 3. Okay, and this is negative, and plus CY multiplied 6 equal to 0, and I'm going to obtain a CY equal to 1,500 pound. I obtained CY, so let's write the total FY equation and obtain also BY. Total FY equal to 0, 3,000 minus 1,500 minus BY equal to 0, and BY equal to 1,500 pounds. So let's solve the second part, this part. Okay, so for this part, yeah, for example, this is our beam, and I have an AY, I have an AX, and also I have a moment as MA. Okay, and I have here as BY was at this for this point, it was upward direction, so it's going to be here as a downward direction. Okay, so it's going to be downward direction as BY, and I have here 500 multiplied 3 equal to 1,500 pound as the point load. Okay, it is distributed load, but I converted to point load. But now it's okay. I had a free body diagram of the shape. I have also Bx, but it is 0. So let's write the moment equation and obtain Ay. Actually, I don't need to write the moment equation. I can directly write as, how can I say, Ay, for example, total Fy. I can directly write as the total Fy equation equal to 0. And for the total Fy equation, 1,500 plus 1,500 minus Ay equal to 0, and Ay is equal to 3,000 pounds. Now we obtained Ay, so let's find also the moment at A. Total moment at A is equal to 0, and this is going to be minus 1,500 multiplied 1.5. I'm going to show you where is 1.5. This is 1.5 and this is 1.5. Okay, and minus 1,500 multiplied 3, this force, and plus MA equal to 0. And from here, I'm going to obtain at the moment at A is equal to 6,750 pound to feet. Okay, pound feet. Okay, this is going to be pound, sorry. Yes, this is going to be pound. Now we obtained the moments and the shear forces. So now 1 second, I'm going to take the second question to down, and draw the shear and the moment diagram for the first question. So I'm going to draw the moment and the shear diagram here. This is going to be shear, and for example, this is for shear, and this is for moment diagram. For shear diagram, I have at A, if you remember, I have at A as here you can see 3,000 pound as the force. Okay, 3,000 pound. So it's going to be 3,000 pound. I'm going to increase at this amount of force, 3,000 pound, and I'm going to decrease as triangular. Look at here, I'm going to decrease as triangular. This is pin, so I can decrease totally with the whole shape, with the whole beam. Okay, so it's going to be something like that. 500 multiplied 9, 500 multiplied the 9, the whole length of the beam, 400, so 4,500, right? So I'm going to decrease as 4,500, and I'm going to reach at point 1,500. Okay, this is going to be positive, this is going to be negative. This is the point, I guess it is 9, and this is 6, right? So let's check. Oh, sorry, this is 6. Sorry, I confused. This is 6. This is 3. So now this is the point 9. Now we obtain the shear diagram. So let's draw the moment diagram. For the moment diagram, I have a moment at A is equal to 6,750 pound to feet. Okay. So when I take the area of this shape, I am going to obtain, look at here, I am going to obtain as to reach the 2,250 pound feet as the moment. So it's going to reach at this point because I'm going to increase at this amount of area, and then I'm going to decrease at this amount of area, and I'm going to reach the point 0. Yeah, for example, this is going to be point 0 as the moment, but the length as 9, and this point is 0.6 from here to that, the point of the moment. Now we draw the shear diagram also and the moment diagram for this question. For the second question, we are going to draw the shear and the moment diagram. Okay, this is our second question. And for this one, let's write the free body diagram and solve the question. So for this one, it's going to be a free body diagram. I'm going to take from that part to here. First, I'm going to solve this part. For this one, free body diagram is going to be something like that. This is pin connection. Okay, so I have a CY, I have a CX, and I have a DY. I have a 5 kilonewton at the midpoint of this section. So 1.5 meter, 1.5 meter. Okay, so now I have this one. So let's write the moment equation. Total moment at C is equal to 0, and minus 5 multiplied 1.5. 5 is this one, and plus dy multiplied C equal to 0, and dy is equal to 2.5 kilonewton. And from total Fy equation equal to 0, 5 minus 2.5 and minus Cy equal to 0, and Cy is equal to 2.5 kilonewton. Now we obtained dy and Cy. So let's solve the second part from A to this point. Okay, so I'm going to draw the free body diagram of shape. For example, this is AY, AX, yeah, and for example, this is point B. I have a BY, and look at here at C. At point C, for this part, for this section, it is CY upward direction. So for this one, it's going to be downward direction. What is CY? 2.5, right? So okay, this is 2.5 kilonewton. I have 3 kilonewton meter as the distributed load here, but for this I'm going to divide from that part. 3 kilonewton meter here multiply 3 is 9. The midpoint of this shape is going to be 1.5, 1.5. Okay, for B, yeah, from B to that point, it's going to be again 3 kilonewton meter. Multiply this length, and we are going to obtain as 9. And now I have the free body diagram of shape. So let's write the moment equation. Total moment at A is equal to 0. This direction is positive. And when I take the moment, it's going to be minus 9 multiplied 1.5 minus 9 multiplied 4.5 and minus 2.5 multiplied 6 and plus by multiplied 3 equal to 0. And by is equal to 23 kilonewton as upward direction. And let's write the total Fy equation. Total Fy is equal to 0 and 9 plus 9 and plus 2.5 minus 23 and plus Ay is equal to 0 and Ay is equal to 2.5 kilonewton downward direction. Now we got the shear forces and we solved the actually question. So let's draw the shear and the moment diagrams. So for example, this one for the shear, sorry. I'm going to try to solve better. So for example, I'm going to start with here, and this is for shear and this is for moment. So this is point A, and this is point B, and this is point C, and this is point, for example, D. Okay, so A, B, C, and D. Look at here at A, for example, this is A, and B, and C, and C, D, sorry, and this is A. I have a downward direction as shear force, okay, downward direction, 2.5. So, and look at here, I have a here distributed load. So if I have a distributed load at downward direction, and it's going to decrease my shear force to the amount of distributed load. What is the amount of that? 3 multiplied 3 is 9, okay? 9 kilonewton. And it's going to decrease as 9 kilonewton. For example, it's going to be at this point, and it's going to be 11.5. 9 plus 11, 9 plus 2.5, 11.5. So, and now I have at B, what is B? At B, what is the shear force at B? 23 kilonewton as upward direction. When I applied the shear at B as 23 kilonewton as a reaction of the B at By, and I'm going to reach the point of 11.5, I guess, right? Yeah. I'm going to obtain the 11.5. And then from B to C, look at it, I have again, from B to C, I have again 3 kilonewton meter as the distributed load. When I convert it to the multiply 3, and I'm going to obtain 9 kilonewton as the distributed load. Okay, so it's going to decrease as, for example, it's going to decrease 9, and I'm going to reach 2.5. Actually, the shape, it's going to be as a symmetric from AB to BC, but I couldn't draw it well, okay? But it's going to be as a symmetric. And now at C, I have 2.5 as shear force. Now you can see. So there's no any force from from C to until the force applied as 5 kilonewton. Okay, there is no any force between this 2 points. Okay, so I'm going to reach as 2.5, and then the force will apply as 5 kilonewton, and I'm going to reach as 2.5. And then I'm going to close at 2.5. So it's going to be negative sorry, negative, positive, positive, and negative. Okay, so now I have the shear diagram. Sorry, I couldn't draw a symmetric. I really apologize. Okay, and now let's draw the moment diagram, but I'm going to try to draw the moment diagram as symmetric. Yeah, for example, the shape is going to be here. This is B. And now I'm going to decrease at this amount of area. Okay, I'm going to start with A from 0, and I'm going to decrease at this amount of area. How I'm going to calculate the area of this shape? It's going to be 2.5 plus 11.5 over 2 multiplied this length. What is this length? 3 meters. Multiplied 3, and this is 21. So I'm going to decrease as parabolic and as 21. And this shape, look at here, this shape is actually it is the same. 11.5 plus 2.5 over 2 multiplied 3 is going to be 21. And I'm going to increase as 21. But again, it's going to be parabolic, okay, from this point C. And then look at here, this is rectangular, so it's going to be as a triangular, I guess. You know that. So it's going to be 2.5 multiplied 1.5, 2.5 multiplied 1.5, and this is going to be equal to 3.75. Okay? It's going to reach as 3.75, and this is going to be linear, okay? And then I'm going to decrease at this amount of area. This is, again, it is the same, 2.5 multiplied 1.5, and it's going to reach to 0. I'm going to decrease because I'm going to decrease at the same amount. Now, I guess you understand how we are going to draw shear and the moment diagrams. If I did anything wrong, please comment. I'm going to try to fix the questions and try to make the channel and the questions for you better. So if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. So see you for the next question.